Hello, everybody. Welcome back. Hope everybody's doing all right. So this will actually be our very last remote learning lesson right here. We will have a test next week. I got some pretty good response on the survey, so we will also be looking at having a video conference call review session. I'm not exactly sure what time that's going to take place. I'm looking at that a little bit later today, but we will definitely have one. So make sure you're checking Google Classroom because I will post about what time that's going to happen. Okay. All right. So our last lesson is going to be graphs of logarithms. We started talking about logarithms last week. And we're going to go through a little bit of review here, and we're going to keep talking about those and focus a little bit on the graphs today. All right. So a quick review. We started this unit by discussing exponential functions. Exponential functions have the variable it has the variable x in the exponent spot. Just as a reminder, I'll give you an example. One of those might look like this. It might be y equals 5 to the x. Okay, x is in the exponent spot. There's really nothing special about the 5. 5 can be whatever number we want, as long as it's positive. And so to show that, we're just going to put a b there. Why a b? Because if x is in the exponent spot, remember what is this 5 called? That's the base. So use a b for base. Okay, nothing special about the 5, and so that can be lots of different numbers. So we're just going to put a b there, b for base. Last time, we discussed the inverse of these exponential functions. So remember, with inverse, x and y end up switched. So if an exponential is y equals b to the x, then the inverse of that would be x equals b to the y. Just switch the x and the y, and there's your inverse. Okay. This particular inverse has a special name. It's called logarithm. Math people invented a new way to write this inverse, because when we get an inverse, a lot of times what we like to do is we want y by itself. And so we had to invent a new way to write this expression right here. And it looks like this. Y equals log with base b written small on the bottom there, and then x, normal size after the little b. Y equals log base b x. And b is the base. And it has that name because it is the same base that came from the original exponential function, way up there. Okay, b is the same base as what we started with up here. So it gets the same letter and it gets the same name. It's the base. All right, and I just want to be very, very forward here. X equals b to the y, or y equals log bx are the same thing, just written differently. These are exactly the same, just the second one is a different way to write the first one so that we can have y by itself. And just a reminder, it's called a logarithm, and these are inverses. This is the inverse of the original exponential function, y equals b to the x. Okay, I'm talking about the inverse of this blue equation, logarithms. Okay, I would like to go through a little bit more review of, we did start talking about the graphs last week, just not in full detail, but it's the easiest way to start looking at the behavior of logarithms. So that's why we did that, and what they're about and what they mean. So we're going to review that a little bit as well. So what we're going to do is we're going to graph the inverse of this exponential function. This is blue because x is in the exponent spot. And so we're going to graph the inverse. What we want to do is graph the inverse of that. The easiest way to do that is start with points, okay, for the blue function. So we would take the blue function and plug in all these numbers. -3 in the x spot, -2 into the x spot, -1 into the x spot. Okay, and what would we get each time? I went through and calculated those for us, so you didn't have to sit through 10 minutes of just calculator stuff. Okay, and these numbers should make sense, right? Like if we do 2 with 2 in the exponent spot, that's 2 squared, that gets us 4. If we do 2 with 3 in the exponent spot like this, that's 2 times 2 times 2, and that's 8. Okay, this is actually the same example that I've used in every single video. I've used the same one, 2 to the x, every single time, just to try and keep things consistent and just as least confusing as possible. Okay, but remember, this isn't asking us to graph this one. We've already done that a couple times in the other videos. It doesn't want us to graph this. It wants us to graph the inverse. So just like I've said a few times, we've been saying it, the inverse just means to switch the x and the y, right? Or instead of y, we have f of x here. But still the same thing. You're going to switch the top stuff, the top numbers, with the bottom numbers. That's all we're going to do. And you can see that's exactly what happened. All these x numbers that were on top, now they're on the bottom. All these f of x numbers that were on the bottom, now they're on the top with x. So this is the inverse. And remember, we call this for these, these are special, and they have this name logarithm. So all I did here next is I just took these points and used these points to make dots on the graph. This one is over 1, up 0. So there should be a point over 1. Yep, there it is. And it's up 0. We should have another one over 4, up 2 is there. So let's start in the middle. Over 4, up 2. Yep, there it is. Okay, so all I did was take these numbers, these points right here, and I just made dots on the graph. That's all I did. I'm going to connect them now, make a nice curve, and that's our logarithm shape right there. And remember, this has a boundary line, and it's this orange one. And the logarithm's boundary line is straight up and down. It's a vertical boundary line, okay? I'm going to go through and talk about the different ways that we described this really quick, just as a reminder, just kind of putting some words to describe what is this looking like. Okay, the logarithm graph starts steep. It's going up really fast at the beginning, and then it starts to flatten, right? That's what we're seeing. It's getting more flat. But something that was very important to the logarithm is that it never totally flattens out. It goes up and up and up and up forever. Just the farther you go, the slower it's going. Okay, we noticed last time that all the x's are positive. There's not a 0 up there, and there is not any negative numbers. They're all positive. Okay, and we already noticed that it does have a vertical asymptote. Remember, asymptote is just a very fancy word for boundary line. So when we say asymptote, that's that orange boundary line on the graph there. Okay, so just trying to make sure I come back to this because it can be a little bit confusing. So just want to revisit this a little bit. Why can't x be 0? And it's because of the original function, the blue function. Okay, in the original function, the blue one, it didn't matter what we plugged in. All of the bottom numbers, all of these y numbers were always greater than 0. Okay, so, and that's because there's nothing you can put in here in the x spot. The blue one, with the blue one here, when x is in the exponent spot, there's not any number that you could put there. You could put negative 1,000 if you wanted to, and it's just going to be a really, really small positive decimal. Doesn't matter what you put in that x spot right there. You can never, 2 to that will never be 0. And it'll never be negative either, actually. And that's why all of our x's on the red side are all positive. Not 0, not negative. They're all positive. Okay. So what I want to do now is talk about the parent function and general form for logarithms. I'm going to put a little snapshot of the graph we were just looking at right up here. Helps to look at the shape a little bit. Okay. The parent function. Remember, parent function, this is as easy as it gets. These are the simplest kinds of functions, and all of the more complicated ones are just one of these with something added to it or built on. Okay? And the general form for these looks like this. F of x equals a times log base b, and then in parentheses x plus h, and then outside the parentheses we have a plus k. And I know this looks kind of big and ugly, and I don't want to deal with learning how to do this equation right here, but I want to point something out that we kind of have done this before. We've had stuff where we've talked about a, h, and k, and what do they do to the graph. Okay, so we have talked about this before, and it's not always obvious. Why do math people pick a k, or why do they pick an h, or why do they pick an a? And I don't really have a good answer for why they picked h or why they picked k. But one thing I can tell you that's nice is they will mean the same things that they have meant before. Let me show you exactly what I mean. I'm going to bring you over to Desmos here really quick. Okay, this is that same equation. Okay, same equation, just in Desmos, okay, using the same equation. And this is actually the same exact graph that we were just looking at, okay? So let's mess with these letters and see what they do. You got the plus k on the end. What is that going to do if I make k bigger? Let's see. All right, so we can see what's happening to the graph. As they make k bigger, the whole thing is just sliding up. What happens if I make k smaller? Or if I make k negative? If I make k negative, then it slides the graph down compared to where it started. Okay, so k is an up and down slide. And if you go back and look at when we talked about this stuff for the exponentials, you'll see that k meant the same thing. It meant the same exact thing. K, just like it always has whenever we've talked about k is a vertical slide. So it slides the graph up or down. Okay, so now we know you should just know what each letter means. K is always the vertical slide. And then if you know that, if you memorize that k is the vertical slide, no matter what we're talking about, k is always a vertical slide. Then you just got to look at, okay, well, where's the k spot for this type of equation that we're talking about? Where's the k spot? Okay, so let's go ahead and talk about the other letters too. Next thing I want to look at, we looked at k, we looked at h. This time h is on the inside of the parentheses with x. Okay, k was a vertical slide. It may move the graph up or down. So you might have a guess already as to what's going to happen if we change h. So if I make h bigger, what happens? The graph is sliding to the right. So what if I make h smaller? What happens? We can see it if I make h smaller, and even more so if I make it negative. Now it's sliding to the right. Okay, so the letter k made the graph move up and down. The letter h makes it move side to side, or horizontal, right? Side to side, that's horizontal. And just as it always has, h is kind of funky. It does the opposite of what you expect it to. So if you make h positive, it doesn't move. It moves the graph to the left. Actually, it's the opposite of what your straightforward guess might be. And if you make it negative, it actually moves it to the right. Okay, so I'm going to put this back now. And we'll put that on our notes here. That h is a horizontal slide. It slides the graph left and right. And the h does the opposite of what you think. If it's positive, then the graph will move left. This stuff should hopefully be sounding familiar, okay? Because like I said before, k always means an up and down slide. H will always mean left to right. Now we still need to talk about a. So let's go look and explore a. So here I've got a thing for a. I can make a bigger or smaller. Let's see what happens if I make a bigger. And you can see that this one spot right here is staying still. This first one right where it's crossing the x-axis there, that's staying still. So if you just look at what's happening, oh, and that's h. If I'm making a bigger, it's stretching that graph up, right? It's starting from this same x-intercept, but now it gets a lot farther up the graph a lot faster. So a is stretching our graph upwards, or it's the stretch to our graph. What happens though if we make a less than 1? We started out at 1. What happens if I make it less than 1? Well, then instead of stretching the graph, now we're squeezing it or squishing it, okay? And that's because, like, if you double something, right, then you got more. And if you have something at 0.5, you have something, it should get smaller, right? So a big A is our stretch or squeeze. If A is bigger than 1, it's going to stretch, and it's going to squish the graph or squeeze it if it's in between 0 and 1. And I bet some of you know exactly what we're going to look at next. What if A is negative? We look at this all the time. What happens if A is negative? Our graph flipped. If it's A is positive, look at that. It starts at the bottom and goes up. If A is negative, the graph starts from the top and comes down. Okay, so A is going to flip your graph if it's negative. That's exactly what's going to happen because you're taking what you had and you're multiplying by a negative number. So anything that's positive will become negative. Anything that's negative will become positive. So A, if it's negative, if you have a negative number in this A spot, then it's going to flip the graph vertically. It's going to take the top and flip it down to the bottom, and also take the bottom and flip that up to the top. Okay. Now we do have one other letter to talk about here, and that's B. What's going on with B? Okay, so we're going to come back over here. I'm going to put A back to 1, so it's like it's not even there. Okay, and so I started out with B being 2. Our base is 2. So this is, like I said, this is the same graph that we've been looking at over and over and over again, where we have a base of 2. All the examples that I've done have been the same one. Okay, so if I make B bigger, it actually squishes the graph. It's almost like the opposite effect of A. And then let's look at what if B is below 1. If B is below 1, it flips the graph. That's kind of strange. Then it starts at the top. So there's 2 ways to flip the graph. You can have a negative A, or you could also have a B that's under 1. Notice something here, though. We can't, once we do 0 or negative for B, there's no graph. There is no graph. And it comes back to, I discussed why it's the same B from the exponential functions, right? So if, I'm not going to spend a whole lot of time on that right here. If you want to know why the B can't be negative or 0, go back to the first video that we did as remote learning, and it's in there why B can't be negative. And it also can't be 1 either. It can be in between 0 and 1, or it can be, see, there's no graph for 1, or it can be above 1. So if B is bigger than 1, it's normal, starts at the bottom and comes up. If B is a decimal that's between 0 and 1, then it starts at the top and comes down. Okay. So let's go ahead and take note of that right here. So we've got all of the information that we need on one slide here. If B is greater than 1, then the graph starts at the bottom. If B is between 0 and 1, then the graph starts at the top. Okay. It will always cross the x-axis, though, no matter what. It will always be use the top and the bottom. Just question of, does it start at the top or does it start at the bottom? All right. So the next couple things we need to talk about are asymptote, because we do have a boundary line. It's that orange one. We also need to talk about domain and range. Okay, so we have a boundary line, right? So that's our asymptote. Asymptote just means boundary line. And it's vertical. It's straight up and down. What does that mean? Well, that means we need an x equals equation for a straight up and down vertical line. We need an x equals equation. And what is x going to be equal to? It's really not too complicated. How do we move this orange line? How did we move things side to side? Oh, that was h. H is how we move things left or right. Okay, so h needs to be a part of this, and it's just negative h. Okay, and the negative is there because h does the opposite of what we think. If we make h positive, then the graph is going to move to the right. It's going to move to the left. If we make h negative, then the graph will actually move to the right. So that negative is just showing that when we have an h, it does the opposite of what we would normally think. Okay, so, but that's not too bad. If you need to figure out the equation of the asymptote, the equation for the asymptote, when you're looking at a homework problem, every single one of those that it's asking for an asymptote of a log, you just need to put x equals, and then negative whatever that h number is. Look at whatever number is in the h spot and put the negative of that number, and boom, you're done. X equals negative whatever h is. Just put that just put negative and then whatever number h is. Okay, and that's it. Okay, so the next thing we need to talk about is domain. And domain, remember, is all of our inputs. It's all of our x numbers. So if our boundary is at negative h, well then what's okay? What x's are okay to plug in? Any x that's bigger than that number is okay to plug in. So the domain for these logs will always look like this. X is greater than negative h. And these kind of match up, and they should. This is our boundary line, right, at x equals negative h, and all of our x's are okay as long as we're bigger than that, which is why the equal sign changes to a greater than sign. So if I'm asking for the domain in a homework problem, it should look exactly like this. X is greater than negative, and then all you got to do is whatever numbers in the H spot, just put it right here in this H spot. Okay, just match them up, take the H number, put it in here. X is greater than the negative of whatever number is in the H spot. Okay. Now, last thing, the range. We talked about on the last slide how this graph will start at the bottom and it will go up and it will start to flatten, but it will not flatten completely, right? It will keep going up and up and up forever. So that means at some point, you get to 5. You go a little bit farther, you'll get to 10. You go a little bit farther, you'll get to 15. Whatever number you want to go to, you'll get there. It might take long. You might have to go very far to the right, but you can get that far up the graph. And so that means our range, that's all of our y numbers, are all real numbers. It will go all the way down and go all the way up forever. So our range is all real numbers. All right, I want to do a couple of examples here. I wanted to make sure I did specifically one of these because this is the one that we kind of problem that we struggled with the most from that very first assignment. I put the general form of the logarithm up here, okay, just because we're going to need to reference that. And so the problems I'm talking about go like this. First, the student graphs a function, f of x equals log base 7x, and then they graph a similar function, g of x equals log base 7. Now instead of x, we've got an x plus 2 inside the parentheses, and then we've also got a minus 5. And the question is, how is the g of x graph different from the f of x graph? Okay, so we just want to look at these two equations. They both have the same base, and for these questions, they always will have the same base. They will. All right, so we're just looking at the other things. And I want to know, based on the equations, how are the graphs different? Okay, so what I saw a lot of you answer the first time you had questions like this was you would say, okay, well, there's a plus 2 now by the x, and there's a minus 5 on the end. And that's great. Those are the things that you should be noticing, but that doesn't answer the question. You told me what's different about the equation. I don't want to know what's different about the equation. I want to know what's different about the graph. Okay, so you do need to know this stuff. You do need to see, oh, there's a plus 2 there. That's different. And there's a minus 5 now. That's different. Okay, good. We do need to recognize those, but we need to take it a step further. Okay, so the negative 5 is in the K spot, right? If you compare this, where's that negative 5? What letter is that in the general form of the equation up here? That negative 5 is in that K spot. And what does K mean? K is a vertical slide. So we have a negative 5 on an up and down slide. The negative means it's going to go down, and so the graph slides down 5. That's what changed from F to G. To get from F to G, you would have to slide down, take the F graph, slide it down 5 to get to G. That's not the only thing though, right? We also have that plus 2. And what spot is that plus 2 in right here? What letter is that plus 2 if we put the g of x with the general form? What letter is that plus 2? What spot is it in? That's in the H spot, okay? The plus 2, if you could just compare these, it's in the H spot. And what does H mean? Well, H was the left to right slide, okay? And remember that if you look back at the last slide, H does the opposite of what we think. So a plus 2 is going to slide the graph left, okay? So if you wanted to get from the F graph to the G graph, you slide down 5 and you slide left 2. And that's how you get from F to G. Okay, what I've just boxed up right here, this is the answer that I need to be seeing. Okay, you'll get like some partial credit for telling me, oh, there's a plus 2 and a minus 5, but that's really not what I'm looking for. You really need to, okay, what spot is the plus 2 in, and what does that mean? Okay, what spot is the minus 5 in, and what does that mean? What I have here in the box, this is what you need to tell me to get full credit on these problems. Okay, you need to tell me slides, which way, and if there's an A number, tell me if it's stretched, tell me if it's squished, and tell me if it flips. Those are the kinds of words I'm looking for when you answer these questions. Okay, so I wanted to make sure I did one of these examples so you know exactly what I'm looking for. Okay, I've got just one example left, and it's how to graph a logarithmic function. Okay, so these actually are going to be pretty simple. you're going to use the same 3 points every single time. And those points are going to look like this. B, comma 1, 1, comma 0, and the last one is 1 over B, comma, negative 1. Okay. I will only be giving you log functions like this one, log base 4x. Notice there's not plus anything in the h spot. There's not plus anything in the k spot. There's no number in front being multiplied. They will always be these super simple ones. We're not going to do the complicated ones. It's always going to be like this, and you're always going to use these same 3 points. Okay. Once you have these 3 points, just make dots on the graph and make a curve. Okay, and that's all you got to do. So let's do, these are the steps you should do for every single problem on the left. How to graph one of these, just do steps 1 and 2. That's all you got to do. And now I'm actually going to do that over here on the right side for this example. Okay, so we know we're going to need to figure out what B is. We need B. What's B? Well, it's our base. That's this little number right here, 4. Okay, so that's our B. So the first point I need is 4, 1. B, comma 1. What number is B for my example? That little number is 4, so I need 4, comma 1. Boom, there's 1 point already out of the 3. The second one, it's always going to be the same every single time. 1, comma 0. And there you go, that's it. And then the last one, you just got to flip the first one. 1 over 4, make that a fraction, 1/4, comma, negative 1. So the 1, 0, negative 1 for the y numbers, those should never change. You should be using the same ones. So anything we really had to figure out was the 4 and the 1 over 4. And you've got your 3 points. Boom. Now all you got to do with these is plot them on the graph, make dots. There's my dots. 4, 1 over 4 up 1, and then 1, 0 over 1 up nothing. And the last one over just 1/4 and down negative 1. Okay. And then I'm just going to connect those with a curve like that. Okay. It's really important that when you're coming towards 0, you should never cross the y-axis. You should never cross the y-axis. If you cross the y-axis, you will lose some points there, and you should be getting flat over here. I'm not looking for anything super brilliant, hanging in an art gallery. As long as you're getting this general shape, your points are in the right spot, you got this kind of looking shape, and you stay to the right of 0, you'll be just fine. Okay. But this is it. These 3 dot points, make those 3 dots and connect them. And that's all you got to do for one of these problems. Okay. All right, well, that's all I've got. So like I said, another reminder, make sure you're looking on Google Classroom for an announcement about exactly what time that review is going to happen. But again, the good news is this was our last lesson. There won't be any more of these coming out. So get this one knocked out, get the homework on it done. And then next week we'll get that review, get you ready for the test, take it, and then you'll be done, at least for my class. Summer is right there. We're almost there. Just keep staying positive, pushing through, okay? And I'm looking forward to seeing as many of you as possible on the review. All right, so I guess other than that, that's all I've got, okay? Everybody stay positive and take care.